Okay, today we are solving quadratic equations, and we know we have it when we can solve by completing the square. This is video 1 of a two-part lesson. Okay, you do not need to write anything on this slide. I repeat, you do not need to write anything on the slide. It's just an introduction. Now, let's say we were trying to solve this quadratic equation. The first thing we would try to do is to do factoring. Okay, but when you notice and you try to do factoring, put a -7 on top, -4 on the bottom, there is no values, there's no factors that when multiplied will give you -7, yet when added would give you -4. So we cannot use factoring to solve. If we were to try to use the square root method, are we able to? We're not able to because there is a bx term. It is -4. Remember, we need it to be 0x in order for us to be able to use it and put it in this formula. So we cannot use factoring, we cannot use square root method. There's a third method that we can use that is called completing the square. Now, before we learn how to complete the square, we must learn what a perfect square trinomial is. A perfect square trinomial is a trinomial that is a perfect square of a binomial. Let me give you some examples of that, what that would be. By the way, you should be writing this slide down already. Let's take, for example, we have x plus 5 squared. Well, when we go to multiply this out, which is x plus 5 times x plus 5, we can either use FOIL or we can use distributive property. Let me show you how the distributive property will look. Remember, you will need to split the first one, and then you multiply both x and 5 by the second binomial. X times x is x squared. X plus 5 is 5x. Hopefully this is just review. 5 times x is 5x. And then 5 times 5 is 25. So now when you add it together, you get x squared plus 10x plus 25. This would be a perfect square trinomial. I'm just going to write PST. Okay? So that would be an example of that. Here's some other examples. Let's say we take x minus 8 squared and we do the same thing, distributive property. You would get x squared minus 16x plus 64. Another perfect square trinomial. Now, if we were to factor perfect square trinomials, this is something that you also want to write down. We can also do that. For example, we have x squared plus 6x plus 9, and notice the uniqueness of factoring a perfect square trinomial. We put 9 on top, 6 on the bottom, and what would be your factors? Well, 3 times 3 equals 9, and 3 plus 3 equals 6. Therefore, my factors are x plus 3 and x plus 3. A equals 1, therefore we don't have to do anything else. But of course, we can rewrite x plus 3 times x plus 3 and rewrite it as x plus 3 squared. It means exactly the same thing. So I want you to factor these 4 problems on your own. Okay, so go ahead and pause the video here, work these 4 problems, factor them out, and then you can check your answer. Pausing now. Okay, so let's see what you got. On the first one, your answer should have been x plus 4 squared. Okay? Now check out this shortcut. If you happen to have a perfect square trinomial, well, just square root this. Well, 16 square root is 4. And then whatever the sign in front of the 8x of the b term is, that's what goes in here. Okay? So for the second one here on the right, I could actually do this shortcut. X, I see there's a minus sign, and then what's the square root of 81? 9. And I would get my answer. Okay? So there it is, x minus 9 squared. Same thing here. Oh, excuse me for that. X, what's the sign in front? Plus, what's the square root of 1? 1 squared. So you can come up with a shortcut versus having to use the AC method and working from there. So there's the answer. And the last one, you should have got an x minus 5 squared. All right, continue to write this down. When you do not have a perfect square trinomial, you can create one. This process is called completing the square. Okay? There's a small formula you can use for that. It is b divided by 2 squared. You'll see how this applies. For example, let's say you're given x squared minus 18x, and you're wanting to complete the square. You're trying to find out what can I put for c, what can I replace c with to turn this into a perfect square trinomial. Well, you can take negative 18, as she's right there, divided by 2 and square it. Okay? Well, negative 18 divided by 2 is negative 9. And then square root, and not square root, but square negative 9. And you get 81. So now I have a perfect square trinomial. Same thing with this one, right? Take negative 22. Well, divide that by 2. And then you would square it. What do you get? Go ahead and pause here and do that. Do negative 22 divided by 2, square it. You should have gotten 121. Okay? Negative 22 divided by 2 is 11, or negative 11. And then you square that, and you get 121. The third one is unique because you end up with a fraction, 7 divided by 2. You cannot simplify that. But you can square that. 7 squared and 2 squared then would give you 49 over 4. I'm just showing you that is possible, although we will not be dealing with any odd bx terms. The only time you will use this method of completing the square would be whenever you have an even b term. Okay, so if we ever have a perfect square, notice how these two are perfect square trinomials. We ever have perfect square trinomials, we can actually use the square root method. All right, so this is really doing what we learned on square root methods, but applying it to a perfect square trinomial. So let me show you how this would look. Looking at example number 1. If you have a perfect square trinomial, you can 1, factor the perfect square trinomial. That's step 1. So I'm going to factor this. If you remember the shortcut, you should be able to come up with your answer quickly. Okay, remember that's a plus. Notice that we're not trying to get 0 on the right side. With perfect square trinomials, you leave it as is, and then you just try to factor it. But if you don't remember how to use the shortcut, remember you can always use the x method. Well, what two numbers multiplied give you 4 and added give you 4? You should come out with 2. Okay, so then there we go. I have factored the perfect square trinomial. Okay, I've done step 1. There we go. Then step 2 says to solve the equation using square roots. Okay, that would be step 2. Well, how do I get rid of a square? Well, square rooting. Remember how we used in the previous video that you saw? You would see something like this. And then to solve for x, you would square root both sides. Well, you can do that here also. You can square root the left side and square root the right side. The reason we do this is to cancel out this square. So now I end up with x plus 2 on the left side. And then what is the square root of 25? It is positive or negative 5. There you go. X plus 2 equals positive or negative 5. And then remember, to solve for square root, we're trying to isolate the x. We're trying to get the x by itself. So I'm going to subtract 2 from both sides. Okay? We subtract 2 from both sides. This cancels out, and we're left with negative 2 plus or minus 5. You just write it in front of the plus or minus sign, or the positive or negative sign. And now we do the math. What is negative 2 plus 5? And what is negative 2 minus 5? And we come up with our two solutions, which would be 3 and negative 7. Negative 2 plus 5 is 3. Negative 2 minus 5 is negative 7. Let's try that same steps for number 2. Factor the perfect square trinomial. Okay, well, factor the perfect square trinomial. Once again, you can either use the x method, or maybe you've already caught on to the shortcut, minus sign in front of the b, square root the 36, and what do you get? You should get x minus 6 squared equals 81. Next step is what? Well, you can always reference over here. What's my next step? That's right. You want to square root both sides. There we go. We do that to cancel out the square on the left side. So now we just have x minus 6 on the left, and go ahead and square root 81. That's a perfect square number. So we end up with x minus 6 equals positive or negative 9. Over here we subtracted 2 because it was a plus sign. Here it's a minus sign. We must add 6 to both sides. So there we get 6 plus or minus 9. And then do the math. What is 6 plus 9? What is 6 minus 9? 6 plus 9 is 15. 6 minus 9 is negative 3. And those are your solutions. The key word for this lesson is bumblebee. Okay, so this is part 2 of completing the square, solving quadratic equations by completing the square. So we have been factoring with a perfect square trinomial on the left, but what happens when you do not have a perfect square trinomial? Okay, well, notice here we do not have a perfect square trinomial, x squared plus 8x plus 7. We can create one. This process is called completing the square. Here are the steps for that. First, you want to rewrite it as x squared plus bx equals c. That means I'm going to subtract 7 from both sides. That cancels out. And you will end up with x squared plus 8x equals negative 7. Another way I would write this is in this manner. X squared plus 8x, excuse the bad 8 and x. Okay, let's try this again. X squared plus 8x plus, and now I would put a blank, equals negative 7 plus blank. The reason is we're going to fill in these blanks with a number by doing step 2. Take half of b squared, then add this to both sides. We've seen this already, but we've seen it as a formula. Okay, there it is. B divided by 2 squared. In this case, b equals 8. So we can replace that b with 8. And now we do 8 divided by 2 and squared. Well, 8 divided by 2 is 4. 4 squared is 16. So we know we're going to add 16 to both sides. Now we have a perfect square trinomial, and we need to add these two together. So we come up with, there's adding 16 to both sides, we come out with x squared plus 8x plus 16 equals 9. Now the rest of this is just like part 1. Factor the perfect square trinomial. There we go. We factored this trinomial. We got x plus 4 squared equals 9. Now continue with the square root method. Okay, how do we get rid of the square? We square root. There we go. That cancels out. And then what's the square root of 9? That's a perfect square. We end up with positive and negative 3. Keep solving for x by subtracting 4 from both sides. So we rewrite this as x equals negative 4 positive or negative 3. Now we just add negative 4 plus 3 and negative 4 minus 3. Negative 4 plus 3 is negative 1. Negative 4 minus 3 will give us negative 7. And those are our solutions. That is how we solve quadratic equations by completing the square. Okay, so let's look at this example now. Doing the same steps. Is this a perfect square trinomial? It is not. So we need to subtract 27 from both sides. That's how we end up with negative 27. Remember, the way I would like to write this, just to remind me that I need to complete the square, is I can put blanks and then negative 27 plus blank. And then I'm going to fill those in. My b is negative 12. Now I need to divide by 2 squared. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So I'm going to put my 36 there, and I'm going to put my 36 there. Simplify this side, and we come up with x squared minus 12x plus 36. Now I do have a perfect square. I can go ahead and factor that. There you go. X minus 6 squared. If you're still having trouble of how I go from here to here, then you can make note of that. That way I can help you tomorrow in class. But that's something we learn in part 1. How do we get rid of squares? We square root. That'll cancel that out. In this case, we have another perfect square. So square root of 9 is positive and negative 3. Continue to solve for x by adding 6 to both sides. We can go ahead and we get 6 plus or minus 3. Do the math. 6 plus 3 and 6 minus 3. 6 plus 3 is 9. 6 minus 3 is 3. And there's our solution. Here's an example of when you do not have the terms in the correct side. As you notice here, we have x squared plus 71 equals 18x minus 9. To solve by completing the square, we must have the x squared and the 18x on one side, and then the 71 and the negative 9 on the right side. So we got to do a little bit of inverse operation. Okay, we're going to subtract 18 from both sides. So there we have x squared minus 18x, and now we need to subtract 71 from both sides, and I have x squared minus 18x equals negative 80. I can also rewrite this with my blanks. So this would be 18, excuse my bad writing there, plus blank equals negative 80 plus blank. Now I complete the square. I take negative 18 divided by 2, that is 9. 9 squared is 81. So I'm going to add 81 to both sides. There's me adding 81 to both sides. And there we go. A perfect square trinomial that can be factored now. So I factor that now, and I have x minus 9 squared equals 1. Time for me to get rid of the square, so I go ahead and square root. And then now after I square root, what's the square root of 1? Happens to be 1, so it would be positive and negative 1. Inverse operation, I need to add 9 to both sides. So 9, so I end up with 9 plus or minus 1. What is 9 plus 1? What is 9 minus 1? We get 10 and 8. Okay, so at this time, we're going to look at solving by completing the square, but we're going to get an irrational solution. That means we're going to get a non-perfect square number underneath the radical sign. So you'll see the difference once we get there. So once again, we want to see if this is a perfect square trinomial. It is not a perfect square trinomial. So I must, at this time, I need to add 4 to both sides. That's how I get plus 4 over here. And I also told you you could write this in this manner. You could do x squared minus 2x plus blank equals 4 plus blank. That way we can complete the square. So we use b divided by 2 squared. In this case, we're going to replace b with negative 2. So negative 2 divided by 2 is negative 1. And when you square that, we get 1. So we add 1 to both sides. So we get 2x squared minus 2x plus 1 equals 5 because we did 4 plus 1. Okay, now the rest of the steps are the same. We want to factor the perfect square trinomial. That means we're going to get x minus, what's the number that's going to go there in the middle, equals 5. Well, remember you want to do, if you use the x method, you end up with 1 and negative 2. We get our factors of negative 1. So we get x minus 1 squared equals 5. Next thing is to get rid of the perfect of the square. So we need to square root both sides. We know that will cancel that out. We end up with x minus 1 on the left side. Now notice that we don't have a perfect square over here. So we're just going to rewrite it as radical 5, but with a positive or negative sign in front. And so there we go. X minus 1 equals plus positive or negative radical 5. Continue to work it here. We're going to add 1 to both sides. So we end up with x equals 1 plus or minus radical 5. And this is basically your answer. Okay? Just remember that these are two solutions. This is really 1 plus radical 5 and 1 minus radical 5. So we have an irrational solution where we cannot simplify a radical. So let's do one more example or a couple more examples. Notice on number 11 though that we have terms on different sides. So we want to set it up where we only have x squared and an x. That means we got to do some inverse operations. I'm going to subtract 7 from both sides, and I want to add x to both sides. Ultimately, we're trying to get here. Once again, remember, you can write this as x squared plus 8x plus blank equals 59 plus blank. Okay? The key word is cookie. All right, let's continue from there. We're going to use b divided by 2 squared. That means we're going to add 16 to both sides. 8 divided by 2 is 4. 4 squared is 16. And now we have our perfect square trinomial. The rest of the steps are just like anything else. I factor the perfect square trinomial. X plus 4 squared equals 75. If you don't understand this yet, then make sure you're asking on how to do that. We've done plenty of problems where you factor perfect square trinomials. Now we're going to square root. And we get radical 75. We know radical 75 is not a perfect square, so we're just going to write positive and negative radical 75 on the right side. Now radical 75, though, can be simplified because there is a 25 inside. That's a perfect square factor. So 25 times 3, and when you factor radical 25, or when you square root that, you get 5. That's where I get the 5 radical 3 from that you see right there. Okay? So when needed, you must simplify radicals to be able to continue with your answer. So now the next step to do is subtract 4 from both sides. You end up with negative 4, positive and negative 5 radical 3, and therefore that is your answer. Remember, this is two solutions though, but you don't necessarily have to rewrite it. You can skip 12